Welcome in part 2 of the air engine build, where I just finished drilling the holes in the top part and also here a little bozo hole, because I'm only human. And when I finally finished cleaning up this part and drilling and deburring, and I will do a test fit, I see that these two holes are not in the right place, which means this one doesn't fit. Of course, also because I wanted to prove that I'm only human. So I had to start again, but as you can see, this one fits. Now, these are of course not the right bolts, but I don't have yet, but you've got the idea. The new one fits. This one, scrap, but whatever. Shit happens, right? Now I think it is the right moment to start working on the flywheel. And this one, in my opinion, doesn't look too good. But it's all I have. I looked around here. I don't have other flywheel or flywheel materials. So this one, it will be. And because on the main shaft here, it's a taper, I will cut inside here the same taper. And to be able to install my top slide at the right angle, I will install the original part. This is of course the center part of the fan flywheel, that wasn't it. Install it here and then I can give it a touch of indicator. Because I don't have the right tool to install my dial indicator for inner bore sweeping things, I installed my boring bar here. And the tip of the boring bar can sweep inside the bore taper. And the tool slide, the tool post, is set just nipped by hand. It's not tight, it's not loose, it's between two, which means I have here a rotation. If now I push a tiny bit my bar and I keep pressure on it, it will touch the inside of the bore. And now I can move my top slide. The indicator is of course on this side, and as you can see, no movement, which means my top slide is in the right angle. I showed the same system a long time ago in another video that I don't even remember which one, but I did it on this lathe. Because this chuck is too small to hold the part, and in here there's a rim, but it's really tiny, I will hold it in the forge-out chuck. I managed to dial it in at the outer rim here at less than 1/10 of a millimeter. So that's good. Of course the inside bore here is moving a bit, but look at this one. That's not too bad. Right, let's make this boring first at the smallest diameter, which is 23, and now it's 21. More speed. That's close enough. Right, let's start cut the taper. Before I finish it, let's do a test fit. There's a tiny bit of play. It will work. The finished product. Well, almost. But the thing seems to fit on here. And there is more than enough stick out in on the shaft to put the bolt in place, so that's good. And I turn down this length here of this central hub, so I have a gap here. Because what I would like to do is to install between two here this little sprocket wheel, I suppose you call it. And I have a cute little chain here that could have maybe exactly the right length that I need to make an overhead valve system. And by that I mean a rotary valve system, of course, just like in this engine. Is that cool or what? Of course, in this thing, the valve system is part of the main shaft of the crankshaft. And what I want to do here is not use the crankshaft as valves, but one on top. And that's why I need this little chain. And to make it work, of course, the crankshaft and this valve shaft, we're gonna call it, needs to spin at the same speed, which means I need 2 times the same sprocket here. And to make it easy, of course, I don't. This one, 19 teeth, and as you can see, I already welded a long time ago for another project. And this one, 25. But I think if I use the 25, my chain will be too short to make the whole turn around the valve shaft system idea. So I think I will have to make another 19. But now that I do here my little layout idea, the chain is on the 19 sprocket, more or less center, and here of course this is just an idea, layout system, and that's not gonna work. Chain too short. And of course I don't have another one. This is a unique piece of equipment, which means this is not gonna work, so I have to find another solution. Let's think. Okay, I think I've got it. I'm gonna reuse the valve idea of this one. As you can see here, the air comes in this little pipe and goes out to the cylinder in the other one. Only in, out. That's all. And of course, here's the eccentric. And you don't want to see it run, do you? I mean, who cares? Of course, this is also a 2-cylinder engine, motor, or whatever you want to call it. But the idea is a little bit different. cylinders are here, valve idea. Now, as you can see, or maybe not, the stem here in the valve is completely loose, can rotate, can whatever. So now it's not touching the eccentric. From the moment we give pressure, it pops out because of the air pressure is pushing it that way. The overpressure that comes back from the cylinder in this longer pipe goes out in the same direction. There's some kind of notch that I milled out here to let escape the air. And that is more or less the idea that I would like to reuse, but even a tiny bit simpler. Here we have a valve body. It's a cylindric part, right? Some kind of pipe. And the air comes in the middle, and air goes out to cylinder 1 or cylinder 2. Inside we have also a cylindrical part. Now this is a piece of paper, but I'm sure you got the point. Cylindrical part that can move up and down, and that will be driven by the crankshaft, of course. For the moment, air out to both cylinders is closed, because of course the engine is in midway. If piston 1 is completely up, this valve will also be completely up. Air can come in to this notch, cylinder 1 will be pushed down, moves also of course the valve, and when the piston 1 is completely down, it means that 2 is completely up, is going to receive air from the middle to cylinder 2. Port 1 is open and the pressure can escape to the open air. And next rotation, of course, cycle starts again. Air can come in to 1 and air can go out again to the open air. If we imagine for a moment that down here is the eccentric that makes the valve move up and down, but the valve is not fixed on it, it's just pushed with a rod, that's all. And because of the air is pushing everywhere except the right way, there is no down force, which means if the valve should go down, the eccentric is moving down, and the valve, there's no way it's moving down, because up here there's no pressure. But I think it will be an easy fix if I use a little spring. Install a spring up here, will push my valve down, and of course the eccentric will push it up. So all I need to do now is to make some kind of eccentric that will be fixed here on the crankshaft, and of course the valve system that can come over here somewhere. And what is very nice is that in here there are 4 mounting holes to hold my system in place, so that's good. Let's start, for example, by making the eccentric. And to do so I will use a piece of my failed cylinder head. Cut a piece off and then I can bolt it on the flywheel. And then of course in the lathe I will turn it in an eccentric. Which means first I have to drill and tap 4, for example, mounting holes in here. And to do so, I think it will be easier if I install my part directly on the table. Which means this vise can go. Of course, like this, it looks stupid, but I wanted to make sure the thing fits. Because when I make something, it's not always guaranteed, of course. Right, let's put this thing in the lathe and bore out this center hole and then make an eccentric. I'm gonna reduce the stick out here because my tool is singing. Much better. Wood. Right, I made an offset here of about 12 millimeters, hoping it's enough. Now I hope my cutting tool is gonna survive because this is gonna be violent. The final passes I switched to an insert for aluminium to have a better finish, but the result isn't really spectacular. But whatever, let's take it out of here and do a test fit. Eccentric finished, and it even fits, and between two here there's a tiny little gap, so just enough free space to let it spin freely, so that's good. And of course I'm not gonna tighten it yet because it needs timing in relationship to the height of the pistons here, but that will be in an upcoming video.